It began as a low rumble, a vibration that you could feel in the soles of your boots long before you could hear it with your ears. A tremor in the ice, subtle at first, like the purring of a sleeping cat, but growing steadily into something deeper, something far more malevolent. On the surface, the day was perfect. The sun, which never truly sets during the Arctic summer, hung low and bright in the sky, casting long, pale shadows across a landscape of blinding white. It was July 2006, and the location was the western flank of the Greenland ice sheet, a place so remote and so vast that it feels less like a country and more like a separate planet entirely. Here, the ice stretches to the horizon in every direction, a frozen desert of peaks and valleys that has existed for millions of years. Standing on that ice was a team of scientists led by glaciologist Sarah Das. They had come to this desolate edge of the world to study a lake, not a small pond, but a massive sapphire blue body of water known as North Lake. To the human eye, North Lake was a masterpiece of nature. It spanned 2 square miles, holding billions of liters of meltwater that had pooled on the surface of the glacier under the summer sun. It was calm, serene, and seemingly permanent, a breathtaking expanse of liquid blue set against the stark, clinical white of the ice sheet. It looked peaceful, it looked solid, but the team was about to learn that in Greenland, peace is often an illusion, and solidity is a lie. The rumble grew louder. It stopped being a vibration and became a noise, a deep, resonant groaning that seemed to come from everywhere and nowhere all at once. Then came the cracks. They didn't sound like ice breaking. They sounded like artillery fire, sharp, explosive retorts that echoed across the glacial plain, one after another, a barrage of gunfire in an empty war zone. The scientists watched in stunned silence as the surface of the lake, which had been glass-smooth moments before, began to tremble. The water was moving, not rippling with the wind, but surging, swirling, agitated by a force that wasn't coming from the air above, but from the ice below. Suddenly, near the center of the lake, the water began to spin. A whirlpool formed, small at first, a dimple in the blue surface, but within minutes it grew into a gaping maw, a vortex of terrifying power that spun faster and faster, tearing at the edges of the ice. The sound changed then. The sharp cracks of the fracturing ice were drowned out by a roar that witnesses compared to the sound of a jet engine taking off directly next to your head. It was the sound of water, millions of tons of it falling not over a cliff, but into the earth. A massive fissure had opened up beneath the lake, a crack in the glacial shield that extended down, down, and further down. The water, driven by gravity and its own crushing weight, was rushing into this abyss with a violence that shook the ground beneath the researchers' feet. This was not a slow leak. This was a catastrophic failure of the container. In less than 2 hours, North Lake, a body of water larger than 2,000 Olympic-sized swimming pools, simply vanished. It didn't evaporate. It didn't freeze. It was swallowed. Imagine standing on the shore of a lake that stretches for miles, a lake you could sail a boat across, and watching it drain like a bathtub in the span of a lunch break. The flow rate was staggering. At its peak, the water was exiting the lake basin at a rate faster than the flow of Niagara Falls. It was a torrent of unimaginable force, plummeting straight down into the darkness of the glacier. The whirlpool, known as a moulin, became a monster, a churning, hungry throat that consumed everything in its path. Massive blocks of ice, some the size of apartment buildings, were torn from the lake bed and sucked into the vortex, disappearing into the depths with a sickening crunch. The scientists could do nothing but watch. They had placed instruments around the lake, GPS trackers and sensors designed to measure the ice's movement. As the water drained, they saw the data coming in live. The entire ice sheet, a slab of frozen water thousands of meters thick, was physically lifting up. The sheer pressure of the water driving into the crack was jacking up the glacier, pushing it off the bedrock below, floating it on a sudden, pressurized cushion of liquid. The ground they stood on, which felt so permanent, was actually rising and falling, breathing like a living thing in the throes of a violent seizure. And then, as quickly as it had begun, it was over. The roar faded to a gurgle, and then to silence. The heavy, oppressive silence of the Arctic returned, hanging over the scene like a shroud. Where there had been a magnificent blue lake just hours before, there was now only a crater, a vast, empty basin of fractured white ice, littered with the broken remains of the lake's surface. Great shards of ice lay jumbled in chaotic piles, like the ruins of a bombed-out cathedral. The water was gone, all of it. Every drop had been sucked down into the belly of the glacier, traveling through hidden veins and arteries to a place no human has ever seen. It was a stark, terrifying reminder of a truth that glaciologists are only just beginning to fully understand. We often think of ice sheets as static, frozen monuments, silent giants that sit patiently at the top and bottom of the world, melting slowly, predictable and dull. But the drainage of North Lake revealed something else entirely. It showed us that the ice is dynamic. It is active. It is riddled with plumbing systems that can move oceans of water in the blink of an eye. And it showed us that the solid ground beneath our feet in the far north is far more dangerous than we ever believed. But the disappearance of the lake is only the beginning of the mystery, because that water didn't just vanish into a void. It went somewhere. It traveled down, piercing through a kilometer of solid ice, dropping into the crushing darkness where the glacier meets the bedrock. It entered a hidden world that has been sealed away for thousands of years, a world of immense pressure, total darkness, and secrets that we are still struggling to comprehend. Where did that water go once it hit the bottom? Did it lubricate the glacier, causing it to slide faster toward the sea? Did it pool in subglacial lakes, waiting to burst forth again? Or did it feed something else, something hidden in the mesh of rock and ice that we haven't yet discovered? The story of North Lake is not an isolated incident. Across Greenland, and increasingly in the Antarctic, these sapphire lakes are forming and disappearing with alarming frequency. They are the visible symptoms of a much deeper, darker process taking place in the veins of our planet's ice sheets, a process that threatens to rewrite our understanding of sea level rise, climate change, and the stability of the world's coastlines. But to understand it, we cannot stay on the surface. We cannot simply watch from the safety of the shore as the water swirls away. We have to follow it. We have to descend into the moulin, past the layers of snow and fern, past the blue ice of the middle depths, and into the black, pressurized heart of the glacier. We have to go where the water goes, into the labyrinth, into the hidden rivers that flow beneath the weight of a million winters, into the darkness where the ice screams as it moves. Because down there, beneath the surface that looks so calm and white, a monster is waking up, and it is hungry. Tonight, we are going to explore that hidden world. We are going to look into the abyss that swallowed North Lake and ask what lies at the bottom. We are going to trace the path of the water from the sunlit surface to the lightless bed of the ice sheet. And we are going to confront the terrifying reality that the biggest threat to our future might not be the melting we can see, but the movement we can't. The plumbing of the apocalypse is hidden beneath the ice, and the faucet has been turned on wide. So, settle in. Let the quiet of the night wrap around you. Forget the noise of the day, the traffic, the demands, the screens. Let your mind drift northward to the high latitudes where the air is cold enough to burn your lungs, and the silence is loud enough to hear your own heart beating. We are going to a place that resists us, a place that breaks our machines and swallows our lakes, a place that holds the history of the world in its frozen grip and the future of our civilizations in its melting waters. The drainage of North Lake was a warning shot, a thunderclap in a quiet theater. It told us that the system is changing faster than we thought possible. It told us that the ice is not just melting, it is breaking, And it told us that to understand what is happening to our planet, we have to look deeper than we ever have before. We have to look into the dark, because the story of what happens next isn't written in the sky or on the surface of the sea. It is written in the crushed rock and pressurized water beneath the ice. And the only way to read it is to go down. The sheer scale of the event Sarah Das witnessed that July day is hard to process. When we talk about climate change, we usually talk about millimeters of sea level rise or fractions of a degree in temperature. We talk about gradual trends, lines on a graph slowly ticking upward over decades. But nature does not always move in smooth lines. Sometimes it moves in jumps. Sometimes it moves in catastrophes. The draining of North Lake was a violent, sudden spasm of a system under stress. It was a reminder that the Earth is capable of sudden, shocking transformation. 1 minute, a lake. The next, a hole. 1 minute, silence. The next, the roar of a jet engine. 1 minute, solid ground. The next, a floating, shifting, cracking raft of ice. This volatility is what keeps scientists up at night. If a lake can vanish in an hour, what else can happen that fast? If a glacier can lift itself off the bedrock in minutes, how quickly can it slide into the ocean? The stability we rely on, the predictable cycles of the seasons, and the slow pace of geological time are beginning to fracture, just like the ice beneath North Lake. As we stand at the edge of that empty basin, looking down into the jumbled chaos of the aftermath, we are left with a feeling of profound smallness. We are tiny creatures, standing on the back of a beast that is stirring. And as we prepare to follow the water down into the dark, we have to ask ourselves, are we ready for what we might find? The ice has kept its secrets for a very long time. It has sealed them away under crushing weight and impenetrable cold. But the seals are breaking. The water is finding a way in. And where water goes, change follows. This is the story of that change. It is a story of power, of violence, and of the terrifying beauty of a world in transition. It is the story of the hidden lakes beneath Greenland and why they are no longer sleeping. It is a story that begins with a crack, a roar, and a vanishing act. But it ends with a question that affects every single one of us. When the ice moves, what happens to the world? Imagine a landscape where the horizon is a lie, a place where the earth and the sky are stitched together by a seam of blinding white, indistinguishable, endless, and utterly silent. It is 1959. We are 800 miles from the North Pole, on the vast, high plateau of the Greenland ice sheet. To the naked eye, there is nothing here but the wind, which scours the surface with the texture of sandpaper, and the cold, which sits heavy in the lungs like a physical weight. But beneath your feet, something is happening. A rumble is vibrating through the snowpack, a mechanical tremor that feels alien in this desolate kingdom of ice. If you were to press your ear to the frozen crust, you would hear it. The grinding of gears, the roar of diesel engines, and the shout of men working against the clock. Because right here, under 30 feet of ancient, compacted snow, the United States Army is building a city. This is not a bunker. It is not a trench. It is Camp Century. And it represents one of the most audacious, terrifying, and hubristic engineering projects in human history. The concept sounds like something ripped from the pages of a science fiction novel, but the reality is gritty, cold, and dangerous. The military calls it the city under the ice. They claim it is a research station, a place to test construction techniques in polar environments. And that is true, in part. But like the ice itself, the surface story is only a thin crust hiding a much deeper, darker purpose. The construction begins not with shovels, but with monsters. Massive, rotary snow millers imported from the Swiss Alps. Machines that look like they were built to eat the world. They roar across the ice sheet, their metal teeth tearing into the snow, throwing arcs of white powder high into the air. They are carving trenches, great, deep gashes in the glacier, some of them more than 1,000 feet long and 30 feet deep. The men working alongside them are tiny in comparison, bundled in parkas, their breath steaming in the 20 below zero air, their faces hidden behind goggles. They work in shifts, fighting the exhaustion that comes from the altitude and the biting cold, driven by orders that come from warm offices in Washington. Watch them as they lower the roof. They don't use wood or concrete. They use corrugated steel arches, massive curved spines that are dropped over the trenches. Then, the snow millers return. They cover the steel arches with the very snow they just excavated. The white powder piles up, burying the steel, burying the trenches, burying the men. Nature does the rest. Within hours, the cold air hardens the snow into a substance as hard as concrete. The roof is sealed. The city is now underground. Or, more accurately, under ice. Inside these buried tunnels, a strange new world begins to take shape. It is a world of plywood prefabs and insulated tubes. They build barracks, a cafeteria, a movie theater, a chapel, a barber shop, and a hospital. They install hot showers and flush toilets, luxuries that seem impossible in a place where the ambient temperature outside can drop to 60 below. They lay down wooden floorboards that echo with the boots of soldiers. They string lights along the curved steel ceilings, pushing back the absolute darkness of the glacial underworld. It creates a surreal, amber glow existence, a place where it is always night, yet always noon, a place where the wind never blows, but the air always smells of diesel, ozone, and recirculated coffee. But running a city inside a glacier requires power, enormous amounts of power. You cannot run extension cords to the nearest grid when the nearest grid is hundreds of miles across a frozen ocean. Diesel generators are heavy, inefficient, and require a constant, vulnerable supply chain of fuel convoys battling the blizzards. So, the planners of Camp Century make a decision that escalates the stakes from ambitious to terrifying. They decide to bring the fire of the atom into the heart of the ice. They ship in a portable nuclear reactor, the PM-2A. It arrives in pieces, dragged across the ice sheet on massive sleds, like blocks for a modern pyramid. They assemble it deep within one of the largest tunnels. The reactor goes critical in October 1960. Think about that image for a moment. A nuclear fission core, burning with the heat of a star, sitting inside a tunnel carved out of frozen water. The heat melts a cavity for itself, a warm, humid pocket in the eternal cold. Steam rises, turbines spin, and for the first time, the lights of the city under the ice flicker steady and bright, powered by the splitting of atoms. Life inside Camp Century settles into a rhythm that is both mundane and bizarre. There are roughly 200 men living here at its peak. They wake up in heated barracks. They eat scrambled eggs and bacon in the mess hall. They watch the latest Hollywood movies in the theater. They get haircuts. They pray in the chapel. But every time they step out of their prefabricated buildings, they are stepping into a tunnel made of ice. The walls glisten with frost. The temperature in the tunnels is kept at a steady, chilly 15 degrees Fahrenheit to stop the roof from melting. You have to wear a coat to go to the bathroom. You can see your breath in the hallway, and always there is the sound, the low, constant hum of the ventilation fans, the distant thrum of the nuclear reactor, and the creaking. The creaking is the first sign that something is wrong, because the men of Camp Century are not living in rock. They are not living in soil. They are living in a glacier. And as we know, a glacier is not a solid block. It is a river, a slow-moving, heavy, relentless river of ice. It flows, it deforms, it reacts to pressure, and it does not like empty spaces. Almost immediately, the physics of the ice begin to assert themselves. The trenches, carved so perfectly by the Swiss machines, begin to change shape. The massive weight of the Greenland ice sheet, millions of tons of pressure accumulating over thousands of years, pushes inward. It pushes down on the steel arches. It pushes in on the plywood walls. The floors begin to buckle. The door frames shift, jamming shut or swinging open. The perfectly straight tunnels start to twist. The men fight back. They form ice-trimming crews. Teams of men armed with chainsaws and picks, whose sole job is to cut back the encroaching walls. It becomes a daily battle. They slice off slabs of ice that are encroaching on the barracks. They shave down the floors that are rising up to meet the ceiling. It is a war of attrition, man against the weight of 1,000,000 winters. The ice moves inches every month. It sounds slow, but when you are living inside it, it feels like the room is shrinking around you. It feels like the glacier is trying to digest the city, and while the men fight the ice with chainsaws, a select group of officers knows the real reason they are there. The research, the ice core drilling, the construction tests, it is all valuable science. Yes, in fact, the ice cores drilled at Camp Century will eventually revolutionize our understanding of Earth's climate history. But the Pentagon didn't spend millions of dollars just for climate science. They are here for Project Iceworm. The plan is staggering in its scale. Camp Century is just the prototype. The goal is to build a network of 2,500 miles of tunnels beneath the Greenland ice sheet. In these tunnels, they plan to deploy 600 nuclear missiles. These wouldn't be stationary silos, easy for the Soviets to target. These would be mobile trains, constantly moving through the dark, icy labyrinth, carrying enough nuclear firepower to level a continent. The ice would hide them. The ice would protect them. The ice would be the ultimate shield. Imagine the hubris of it. To turn the pristine, ancient wilderness of Greenland into a launch pad for the apocalypse. To hollow out the glacier and fill it with weapons of mass destruction. They believed they could conquer the environment. They believed that with enough steel, enough nuclear power, and enough American ingenuity, they could force the ice to submit. But the ice does not submit. By 1962, the deformation of the tunnels is becoming critical. The reactor building is shifting. The heavy equipment is sinking. The carefully leveled floors are turning into roller coasters. The smell of the camp changes too. The sewage sump, a massive cavern melted into the ice to hold the waste of 200 men, begins to smell. The heat from the reactor and the buildings is migrating through the ice in unpredictable ways, softening the very foundations of the camp. The men begin to notice the psychological toll. It's the big eye. They call it the insomnia that comes from living without the sun. But it's more than that. It's the claustrophobia, the knowledge that above your head is 30, 40, 50 feet of snow, and above that, a howling void where temperatures drop to levels that freeze exposed skin in seconds. You are trapped in a bubble, and the bubble is slowly being squeezed by a giant hand. There is a moment, documented in the logs, where the reality sets in. The engineers run the numbers. They measure the rate of the ice flow. They measure the deformation of the steel arches, and they realize the truth. Project Iceworm is impossible. You cannot build a railway system for nuclear missiles in a medium that moves, twists, and crushes everything you put inside it. The tracks would buckle within weeks. The tunnels would collapse. The missiles would be trapped. The glacier is not a passive hiding spot. It is an active, hostile force. The dream of the nuclear fortress crumbles. The prototype, Camp Century, is doomed. In 1964, the reactor is shut down. The heart of the city stops beating. The lights that had burned for years on nuclear fire flicker out, replaced by the roar of diesel generators once again. The withdrawal begins. It is a slow, melancholy retreat. They strip the valuable equipment. They remove the reactor core, carefully shielding the radioactive heart as they drag it back across the ice. But they don't take everything. And this is where the story shifts, from a Cold War curiosity to a modern nightmare. This is where the terror begins for the scientists of today. When the army leaves in 1967, they abandon Camp Century. They turn off the generators. They lock the doors to the prefab buildings. They leave the furniture, the supplies, the vehicles, and they leave the waste. They leave roughly 200,000 litres of diesel fuel. They leave PCBs, toxic chemicals used in the electrical systems. They leave massive amounts of sewage, and they leave low-level radioactive coolant water, dumped directly into the ice or stored in unshielded containers. Why did they leave it? It wasn't just laziness. It was a calculated assumption, a belief based on the science of the time. They believed that the Greenland ice sheet was eternal. They thought the snow would continue to accumulate, layer upon layer, forever. They thought Camp Century would be buried deeper and deeper, encased in a frozen tomb that would never melt, never move, never release its contents. They thought they were burying their trash in a geological vault that would remain sealed for 10,000 years. They were wrong. They didn't account for the heat. They didn't account for the way the world would change. They looked at the ice and saw a statue, but they should have seen a clock. The army evacuates. The last heavy sled rumbles away into the whiteout. The steel hatches are closed, and silence returns to the surface of the plateau. Down below, in the dark, the city waits. The heat of the reactor is gone, so the cold creeps back in. The temperature drops. The frost grows on the movie theater seats. The water in the pipes freezes and bursts, and the ice continues to move. Without the trimming crews, there is nothing to stop the compression. The steel arches groan under the strain. The rivets pop like gunshots in the silence. The ceiling lowers, inch by inch. The walls close in. The plywood barracks are crushed like matchboxes. The chapel, the mess hall, the barber shop, they are all slowly, methodically flattened by the immense weight of the glacier. The city under the ice becomes a ruin, a crushed skeleton of steel and wood, preserved in the dark. For decades, it lies there, forgotten. A footnote in military history, a weird story to tell at a bar. Yeah, we built a nuclear base inside a glacier. But while humanity forgot, the ice remembered. The waste is still there. The diesel is still there. The PCBs are still there. The radioactive water is still there. Fast forward to the present day. High above the crushed remains of Camp Century, satellites are watching. Scientists are measuring. And what they see terrifies them. The Greenland ice sheet is melting. It is not accumulating snow the way the army planners predicted in the 1,950 seconds. The climate has shifted. The Arctic is warming 4 times faster than the rest of the planet. The surface of the ice sheet is lowering. The meltwater lakes are forming. Rivers of blue water are carving through the white, plunging into moulins, drilling deep into the glacier's heart. The boundary between the accumulation zone, where snow builds up, and the ablation zone, where ice melts away, is moving. It is creeping inland. It is moving toward the coordinates of Camp Century. The tomb is cracking open. Models now suggest that within decades, the ice covering Camp Century will erode. The crushed city will not remain buried forever. It will be exposed. And when it is exposed, everything inside it will be released. Imagine the scenario. The meltwater reaches the crushed tanks of diesel. It reaches the PCBs, chemicals that do not break down, chemicals that cause cancer and reproductive devastation. It reaches the radioactive residue. This toxic cocktail doesn't just sit there. It flows. It joins the meltwater rivers. It flows downhill, under the ice, toward the coast. It flows toward the ocean. It flows toward the ecosystems that surround Greenland. It flows toward the fish, the seals, and the people who live there. This is the ghost of the Cold War, rising from the grave. The army thought they were working in a freezer, a place where time stood still, but they were working in a slow-motion river, and now that river is speeding up. The story of Camp Century is the prologue to the story of the lakes. It teaches us the fundamental lesson that we are still struggling to learn. The ice is not just a solid surface. It is a dynamic, volatile, and powerful system. It hides things, yes, but it does not keep them hidden forever. It captures our secrets, holds them for a while, and then, when the balance tips, it spits them back out. The scientists, looking at the radar data today, can see the debris field beneath the ice. They can see the disturbed layers. They know exactly where the poison lies, but they can't get it out. To dig it up would be an engineering nightmare even greater than building the camp in the first place. You would have to excavate millions of tons of shifting ice, handle toxic waste in sub-zero conditions, and risk releasing the chemicals in the process. So they watch, and they wait. The city under the ice was supposed to be a triumph of human engineering. Instead, it became a monument to our short-sightedness. It stands as a warning. We looked at the ice and saw a tool, a weapon, a hiding place. We didn't respect it. We didn't understand that the weight of 1,000,000 winters is not something you can push aside with a snowblower. And now, as we turn our attention to the deeper mysteries, to the vast, dark lakes that lie even further below, trapped between the ice and the bedrock, we carry the ghost of Camp Century with us. Because if a small city built by humans can cause this much trouble, what happens when we start poking at the reservoirs of water that nature itself has hidden away? The water beneath the ice is under pressure. It is filled with gas. It is ancient. And as we are about to discover, it is far more dangerous than a few thousand barrels of diesel. Camp Century was a mistake. But the lakes? The lakes are a ticking bomb. To understand why, we have to go deeper. We have to leave the crushed ruins of the military base and descend further, past the layers of snow from the 1,960 seconds, past the layers from the Little Ice Age, past the layers from the time of the Romans. We have to go down to the place where the ice meets the rock, to the place where the pressure is so intense that the ice melts from the bottom up. This is where the true monsters live. Not nuclear reactors or Soviet missiles, but forces of physics that can lift an entire ice sheet and throw it into the sea. The story of the city under the ice ends in silence and rust. But the story of the water beneath it is just beginning. And unlike the soldiers of 1959, we don't have the luxury of walking away when the walls start to close in. The walls are already closing in, and this time, there is nowhere left to run. Let's go down into the wet, dark, pressurized heart of Greenland. Because if you think the city was terrifying, wait until you see what lies beneath the lakes. It is the summer of 2006, and the Greenland ice sheet is waking up. From the window of a passing airplane, or the lens of a satellite drifting silently in orbit, the scene below looks less like a frozen wasteland and more like a shattered mosaic of white and blue. The sun, circling high and relentless in the sky, has done its work. The surface of the ice, usually a blinding, impenetrable shield of white, is pockmarked with thousands of lakes. They are stunningly beautiful. Their water is a deep, electric sapphire, a color so pure and saturated that it looks almost artificial against the stark, colorless expanse of the glacier. These are supraglacial lakes, literally, lakes on top of the ice, and to the casual observer, they appear peaceful, static, permanent. They look like swimming pools for giants, resting quietly in the depressions of the ice sheet, reflecting the clouds and the sun. But looks, as any scientist working in the polar regions will tell you, are deceiving. These sapphire eyes are not resting, they are waiting, and they are not peaceful. They are batteries charging up with potential energy, millions of tons of water pressing down on the ice, seeking a weakness, seeking a crack, seeking a way down. For decades, glaciologists looked at these lakes and saw them as surface features. Interesting, yes. Beautiful, certainly, but largely superficial. The prevailing wisdom was that the ice sheet was a solid block, kilometers thick, and that whatever happened on the roof of the world stayed on the roof. The The water would eventually freeze, or maybe trickle off the edges in slow, lazy rivers. The ice below was thought to be too thick, too cold, and too solid to be affected by a few weeks of summer sunshine. They were wrong. The realization began not with a roar, but with a disappearance. In the early 2000s, researchers analyzing satellite imagery noticed something strange, something impossible. They would look at a photo taken on a Tuesday, and there would be a massive lake kilometers wide, holding billions of liters of water. Then they would look at a photo of the same spot taken on Wednesday, and the lake would be gone, not frozen over, not drained slowly over the course of a season. Gone, vanished, a hole in the map where a lake used to be. It was a magic trick performed on a geological scale. How do you make a body of water the size of a city disappear overnight? Where does it go? And more importantly, what happens to the ice when it leaves? These questions haunted a team of scientists from the Woods Hole Oceanographic Institution and the University of Washington. They didn't want to just see the before and after photos. They wanted to see the event itself. They wanted to catch the phantom in the act. So, in July of 2006, a team led by glaciologists Sarah Das and Ian Yoffin flew out to the western flank of the Greenland ice sheet. They chose a large lake, a beautiful expanse of blue about 2 miles across, and they began to lay their trap. They installed GPS units around the perimeter of the lake to measure the movement of the ice. They placed water level sensors in the lake itself. They set up seismometers to listen for the tremors of the earth. And then they waited. Camping on the ice sheet is an exercise in vulnerability. You are a tiny, warm speck on a continent of cold. The wind never really stops. It just changes its voice, moving from a whisper to a scream and back again. The light is constant, the sun dipping toward the horizon, but never truly setting, bathing the world in a perpetual, exhausting twilight. In this environment, time seems to stretch and blur. You wait for the ice to speak. You wait for the water to move. For days, the lake did nothing. It sat there, placid and heavy, reflecting the sky. The water level rose slowly as snow melted from the surrounding slopes and trickled in. It was a peaceful scene, the kind of stillness that makes you forget the violence inherent in nature. But beneath the surface, the physics of the ice were reaching a breaking point. On July 29th, the trap snapped shut. It didn't start with a slow leak. It started with a fracture. Somewhere beneath the basin of the lake, the immense pressure of the water found a microscopic weakness in the ice, a tiny crack, a flaw in the crystal lattice. In an instant, the water forced its way in. Water is heavier than ice. It is denser. When it fills a crack, it acts like a wedge, a fluid knife blade driven by gravity. As the water pushed into the fissure, it exerted immense pressure on the walls of the ice, forcing them apart. This drove the crack deeper, which allowed more water in, which increased the pressure, which drove the crack deeper still. This process is called hydrofracture, and once it begins, it is unstoppable. Within hours, the tranquility of the Sapphire Lake was shattered. The entire lake, holding more water than 4,000 Olympic swimming pools, began to drain. But it didn't drain over the edges. It drained straight down. A massive crack opened in the lake bed, and the water began to pour into the heart of the glacier. If you had been standing there, the sound would have been the first thing to hit you. A low, guttural groan rising from the deep, followed by the thunderous roar of rushing water. It would have sounded like a freight train, like a jet engine, like the earth itself was tearing apart. The surface of the lake, once glass smooth, would have transformed into a chaotic whirlpool, a vortex of white water spiraling down into the darkness. In just 24 hours, the lake was gone. Billions of gallons of water, gone. It plummeted through a kilometer of solid ice, carving a vertical shaft known as a moulin. It fell with the force of Niagara Falls, crashing down through the dark, cold layers of history. past ice that fell as snow during the time of the Vikings, past ice from the time of the Romans, past ice from the last ice age. It didn't stop until it hit the very bottom, the bedrock. This was the Phantom Lake. This was the magic trick. And for the scientists watching the data, the implications were terrifying, because that water didn't just disappear. It didn't vanish into a void. It went somewhere. It went underneath the ice sheet. And when water goes underneath ice, it changes everything. To understand why this terrified the scientists, you have to understand friction. A glacier is, in essence, a river of ice flowing over rock. Friction is the break. The rough, jagged bedrock grips the bottom of the ice, holding it back, slowing its descent toward the sea. Without friction, the ice would slide uncontrollably. When the Phantom Lake drained, it delivered a massive, high-pressure pulse of water directly to the interface between the ice and the rock. It was like injecting grease into a rusted engine. It was like pumping pressurized oil into a seized bearing. The water spread out across the bedrock, lifting the entire ice sheet up. Think about that for a moment. The sheer weight of the Greenland ice sheet is almost incomprehensible. It creates pressure so intense that it warps the Earth's crust, and yet, the water from a single lake, driven by the relentless power of gravity, was strong enough to lift it. The GPS units that Sarah Das and her team had placed around the lake recorded the movement. As the water hit the bed, the ice sheet rose. Not much, perhaps only a meter or so, but for a mass of that size, a meter is everything. With the ice lifted off the rock, the friction vanished, the break was cut, the glacier accelerated. The data showed that in the days following the drainage event, the ice sheet moved significantly faster than it had before. It lurched forward, sliding on a cushion of pressurized water, rushing toward the ocean. The Phantom Lake had become a phantom engine, driving the ice into the sea. This discovery, published in the journal Science Times in 2008, sent shockwaves through the scientific community. It upended the old models. It shattered the idea that the ice sheet was a stable, slow-moving giant that would take centuries to respond to climate change. It showed that the ice was dynamic, reactive, and volatile. It showed that the surface and the bottom were connected by a direct, high-speed plumbing system that could turn on in an instant. And the most chilling part? This wasn't happening to just one lake. Across the vast, sun-bleached expanse of Greenland, thousands of lakes form every summer, thousands of sapphires opening their eyes. And as the climate warms, as the melt season gets longer and more intense, these lakes are forming higher up the glacier, further inland, in places that used to be permanently frozen. Each lake is a potential hammer, waiting to drop. Each one is a wedge, waiting to split the ice. The story of the Phantom Lakes is a story of connection. It teaches us that you cannot look at the Earth in isolation. You cannot look at the surface and ignore the depths. You cannot look at the warmth of the sun and ignore the cold of the bedrock. They are linked. They are talking to each other. And the language they speak is the language of water and force. Imagine the journey of that water. Imagine being a single molecule of meltwater on the surface of Greenland. You start as snow, falling silently in the winter dark. You sit there for months, packed in with billions of others, frozen and still. Then, the sun returns. You melt. You become liquid. You join a tiny stream, cutting a channel through the slush, flowing downhill, joining other streams, until you spill into the basin of a great blue lake. You sit there for weeks, staring up at the sky, and then the floor drops out. You are sucked down, accelerating into the dark, falling faster and faster, the walls of ice rushing past you. The temperature drops, but the friction of your descent keeps you liquid. You fall for a mile. The pressure builds until it is crushing. And then, impact. You hit the rock. You are squeezed out sideways, forced into the microscopic gap between the continent and the ice. You become a lubricant. You become a force of nature. You help to push a mountain of ice into the sea. That is the reality of the hydraulic fracture. It is violent, it is hidden, and it is happening right now. But the story of the scientists on the ice that summer isn't just about data points and hydraulic pressure. It's about the human experience of witnessing something that feels fundamentally wrong. There is a deeply unsettling quality to a draining lake. We are used to lakes being permanent features of the landscape. We build our homes near them. We map our borders by them. A lake is supposed to be there. When a lake dies in a matter of hours, when it is swallowed by the earth, it violates our sense of stability. It reminds us that the ground beneath our feet is not as solid as we think. Sarah Das and Ian Joffin stood on the ice and watched the aftermath. They saw the massive scars left behind the jumbled blocks of ice, the gaping moulin, the empty basin where the water had been. It looked like a battlefield. It looked like the aftermath of a bomb, and in a way, it was. It was a thermal bomb, detonated by the changing climate. The years following that discovery were a race to understand the scale of the phenomenon. If one lake could speed up the ice, what could 1,000 do? What could 10,000 do? Scientists began to map the lakes using satellites, tracking their formation and their disappearance. They found that the plumbing system of the ice sheet was far more complex than anyone had imagined. There are rivers flowing inside the ice. There are waterfalls crashing in the dark. There are lakes that drain and refill and drain again, pulsing like a slow, cold heartbeat. And there is another layer to this mystery, one that adds to the sense of dread that some researchers feel. It is the question of feedback loops. A feedback loop is a vicious cycle. In the context of the ice sheet, it works like this. The air gets warmer. More ice melts on the surface. More lakes form. More lakes drain. The water lubricates the bed. The ice flows faster. As the ice flows faster, it moves from the high, cold interior of Greenland to the lower, warmer edges. There, it melts even faster, which creates more water, which creates more lakes, which makes the ice flow even faster. It is a runaway train, and the phantom lakes are the coal being shoveled into the engine. The hydraulic fracture mechanism essentially greases the skids for the ice sheet's demise. It is a mechanism of efficiency, a way for the glacier to destroy itself faster than simple melting ever could. It turns the ice sheet into a conveyor belt, speeding the transport of frozen water into the ocean, where it raises sea levels and changes coastlines thousands of miles away. Between 2002 and 2010, the understanding of this mechanism transformed glaciology. It turned a discipline of slow, steady calculations into a science of catastrophic events. It forced researchers to confront the fact that the ice is fragile, that it can break, that it can move with sudden, terrifying speed. But let's step back from the mechanics for a moment and return to the silence. The documentary For Sleep isn't just about information. It's about the feeling of the place. And the feeling of the phantom lakes is one of profound isolation. When these events happen, they usually happen with no one watching. There is no audience. There is no applause. Just the wind, the cold, and the sudden violent roar of water in the dark. It happens in the blind spots of our world. Think of the energy released in that moment. The potential energy of billions of tons of water falling a mile straight down is immense. It releases heat. It vibrates the bedrock. It creates seismic waves that can be detected by sensors hundreds of miles away. The ice sheet literally quakes. It groans under the stress. If you were to put your ear to the ice during a drainage event, you would hear the beast waking up. You would hear the creaking, the popping, the deep bass rumble of a continent shifting its weight. It is a sound that belongs to a different era of Earth's history, a time when the planet was wilder and more volatile. And yet, it is happening in our time. By 2010, the picture was becoming clearer, but no less comforting. The phantom lakes were not anomalies. They were a feature of the warming Arctic, and they were moving inland. As the summers grew warmer, The melt line, the elevation at which snow turns to water, began to climb higher up the ice sheet. Lakes began to appear in regions that had been frozen solid for millennia. This migration is critical. When a lake drains near the edge of the glacier, the water has a short path to the sea. The lubrication effect is temporary and localized. But when a lake drains deep in the interior, 50 or 60 miles inland, the water is trapped under the thickest, heaviest part of the ice. It has nowhere to go. It spreads out. It lingers. It can lubricate the flow for a much larger area and for a much longer time. It is like moving the injection of oil from the wheels of the train to the engine itself. The discovery of the phantom lakes and the hydraulic fracture changed the way we look at Greenland. It turned the ice sheet from a static monument into a living, breathing, dying thing. It gave the ice agency. It showed us that the ice fights back. It reacts. It has reflexes. When we push the climate pushes the ice, and the ice pushes the water pushes the rock. It is a chain reaction of kinetic energy that ends at our doorsteps, in the rising tides of Miami and Mumbai and Shanghai. The phantom lakes are a warning. They are beautiful, yes. The blue is hypnotic. The silence is peaceful. But beneath that beauty lies a mechanism of destruction that we are only just beginning to understand. There is a specific kind of terror in realizing that the ground is not solid. We rely on the solidity of the earth. We rely on the permanence of the landscape. But in the Arctic, the landscape is transient. It is fluid. A lake is here today and gone tomorrow. A glacier is here this century and gone the next. The phantom lakes remind us that we are building our civilizations on the edge of a world that can change in an instant. They remind us that nature has forces at its disposal that make our engineering look like toys. We can build sea walls, we can pump water, but we cannot stop a mile of ice from sliding when gravity calls it home, and gravity is always calling. As the decade turned, as 2009 bled into 2010, the scientists monitoring the ice saw the pattern accelerating. The drainage events were happening earlier in the season. They were happening in clusters. One lake would drain, creating a shock wave that triggered the lake next to it and the lake next to that. A domino effect of collapsing water. The chapter of the phantom lakes is not a closed chapter. It is still being written. Every summer, the satellites look down. Every summer, they see the blue eyes open, and every summer, they watch them close, one by one, sending their messages down into the dark. We know now where the water goes. We know what it does when it gets there, but we still don't know the limit. We don't know how fast the ice can go. We don't know how much water the bedrock can take before the friction fails completely. We are watching an experiment play out in real time, an experiment with global consequences, and the laboratory is a place of stunning, terrifying beauty, where sapphires turn into ghosts, and where the sound of rushing water is the sound of the future arriving faster than we planned. The ice remembers. It remembers every winter. It remembers every summer. And now, it is reacting to a new kind of summer, one that doesn't end when the sun goes down. In the silence of the sleep documentary, let that image settle in your mind. The vast, white emptiness, the shock of blue, the silence, and then the crack, the rush, the void. It is a cycle of creation and destruction, happening over and over again, far beyond the reach of human eyes, in the cold, indifferent heart of the north. The lakes are phantom, but the water is real, and the water is coming. There is a rhythm to this destruction, a cadence that mimics the beating of a heart or the ticking of a clock. Thaw, pool, crack, drain, slide. Thaw, pool, crack, drain, slide, slide, drain, slide. It repeats, season after season, a drumbeat driving the march of the glaciers. And as we drift deeper into this story, past the phantom lakes and the shattered ice, we have to ask ourselves, what happens when the water doesn't just lubricate the ice, but breaks it? What happens when the force isn't just pushing the glacier, but tearing it apart from the inside out? That is where we go next, into the anatomy of the fracture itself, into the microscopic violence that leads to macroscopic change. Because the phantom lakes are just the symptom, the disease is the heat, and the patient is a continent of ice that is running a fever. But for now, stay with the image of the draining lake. Watch the whirlpool spin. Feel the vibration in your chest. Respect the power of the phantom. It is nature showing us its hand. It is the planet revealing its gears, and those gears are turning, slowly, then quickly, then all at once. The hydraulic fracture is the mechanism of that all at once. It is the tipping point made visible. It is the moment potential becomes kinetic. And in the quiet of the Arctic night, after the water has gone and the roar has faded, the ice settles back down. The wound begins to heal, freezing over, sealing the scar. The glacier waits for the next winter, for the next layer of snow, to hide the evidence of its movement. But it has moved. It has shifted. It is not where it was yesterday, and neither are we. The world has changed beneath our feet, driven by the weight of water and the pull of the deep. The phantom lakes have done their work. They have delivered their message. The question is whether we are listening, or are we, like the ice, simply waiting for the next fracture to open? There is a peace in the aftermath, a stillness that feels almost apologetic. The wind returns to its gentle whisper. The clouds drift on. The sun circles low and golden. If you arrived a day late, you would never know the violence that had occurred. You would see only a depression in the snow, a shadow in the white. That is the nature of the phantom. It leaves no trace, except for the changed world it leaves behind. And as the years 2002 to 2010 drew to a close, the scientists packed up their GPS units, their seismometers, their tents. They flew back to their universities, to their warm offices, and their glowing screens. They processed the data. They wrote the papers. They warned the world. But the ice stayed. The ice remained, vast and indifferent, holding its secrets and its scars. It continued its slow, inexorable slide toward the sea, carried on the back of the phantom water. And in the silence of the north, the next lake began to form, waiting, watching, ready to fall. It begins not with a shout, but with a whisper, a subtle, almost invisible ripple in a map that had been drawn and redrawn 1,000 times. By 2015, we believed we understood the shape of Greenland. We had satellites gazing down from orbit, measuring the height of the ice to the millimeter. We had planes crisscrossing the white expanse, firing radar pulses deep into the frozen crust to trace the bedrock below. We thought the map was finished. We thought the land beneath the ice was a known quantity, a silent, static foundation holding up the glaciers. But the Earth has a way of hiding its most violent stories in plain sight. It is July 2015. In the cool, quiet corridors of the Natural History Museum of Denmark, a geochemist named Kurt Kjær is looking at a map. He is not looking for monsters. He is not looking for catastrophe. He is looking for something mundane, a better way to map the topography of the Arctic. But as his eyes trace the edge of the Hiawatha Glacier in northwest Greenland, something catches his attention. It is a shape that nature does not typically make. Nature, left to its own devices, is chaotic. It builds jagged mountains and carves winding valleys. It erodes rock into irregular, tumbling shapes. It does not draw perfect circles, and yet there it is, a subtle, semicircular arc etched into the edge of the ice sheet. It is faint, barely a ghost of a line, visible only because the radar data from NASA's Operation Icebridge has been processed just so. A depression, a bowl, a distinct curving rim that seems to cradle the glacier tongue as it spills toward the sea. He leans in. The shape is immense. It is not a small kettle hole left by melting ice. It is not a volcanic caldera, for there are no volcanoes here. It is a structure 31 kilometers wide, a gaping maw capable of swallowing an entire city, buried beneath a kilometer of solid ice. Curiosity turns to a cold, prickling realization. To create a circular depression of that magnitude, something enormous must have happened, something violent, something that did not grow from the earth, but fell from the sky. He is looking at a wound, a scar on the skin of the planet that has been bandaged by ice and forgotten by time. But a shape on a map is not proof. It is only a shadow. To prove that the Hiawatha Glacier is hiding an impact crater, to prove that a massive asteroid once slammed into this remote corner of the world, they need more than a suspicious curve. They need to see beneath the ice. They need to strip away the white blanket and look at the shattered bone of the bedrock below. The story moves from the quiet of the museum to the deafening roar of a turboprop engine over the ice sheet. It is May 2016. The team has chartered a research plane, the Polar 6, from the Alfred Wegener Institute. They are flying directly toward the anomaly. Outside the windows, the world is a blinding, featureless white. The Hiawatha Glacier looks peaceful, a vast river of frozen water flowing slowly, silently toward the Nares Strait. It gives no hint of the violence locked in its basement. Inside the plane, the air is thick with tension. They are flying a grid pattern, mowing the lawn of the sky, passing back and forth over the suspected rim. Beneath the fuselage, a powerful radar system is pulsing radio waves downward. These waves are the only things capable of penetrating the shield. They punch through the snow, through the layers of fern, through the hard blue glacial ice, until they hit the rock below and bounce back. On the screens, the echo forms a picture. It is a ghostly, grainy cross-section of the world beneath. And as the plane crosses the edge of the anomaly, the picture sharpens. The bed of the glacier drops. It plunges. The radar reveals a jagged, chaotic rim, a wall of rock rising up from the depths, and then a deep, flat basin. In the center of that basin, exactly where the physics of a hypervelocity impact says it should be, there is a peak, a central uplift, a mountain of rock that snapped back upward like a splash of water when the asteroid hit. The team stares at the data. The silence of the ice below seems to deepen. They are looking at the footprint of an apocalypse. This was not a pebble skipping across a pond. This was an iron asteroid, perhaps 1.5 kilometers wide, traveling at 20 kilometers per second. That is a speed that defies comprehension. At that velocity, the air does not just move out of the way. It turns into plasma. The rock does not just break. It vaporizes. When that object struck northwest Greenland, it would have released the energy of millions of nuclear bombs in a fraction of a second. Imagine the moment. 1 second, the Arctic is silent. The wind sweeping over the tundra or the ice. The next, the sky is torn open by a second sun. The impactor punches through the atmosphere, a spear of blinding light. When it connects with the earth, the ground behaves like a liquid. The bedrock melts instantly. A shock wave expands outward, flattening everything in its path, stripping the land of life, boiling the water, and hurling billions of tons of rock into the upper atmosphere. Forest, if there was forest, burns instantly. Ice, if there was ice, turns to steam, and then the fallout. A rain of molten rock falling back to earth, setting half the hemisphere on fire. A winter that lasts for years as dust chokes the sun. This is what lies beneath the Hiawatha Glacier, not just a hole in the ground, but a frozen memory of a day the world nearly ended. But the discovery brings a new, terrifying question. When? Geology usually speaks in millions of years. We are used to craters being ancient, weathered things, relics of a solar system that was young and violent. But the Hiawatha crater looks fresh. The radar shows that the bottom of the bowl is jagged, rough, uneroded. The ice flowing over it is disturbed, turbulent, as if the wound hasn't quite healed yet. The team looks at the layers of ice in the radar data. In most of Greenland, the ice is neatly stacked, layer upon layer of history going back hundreds of thousands of years. But here, above the crater, the bottom layers are missing. The ice is jumbled, chaotic. It looks as though the crater is young, distressingly young. Could it have happened while humans were watching? The thought hangs in the air like a threat. If this rock fell 3 million years ago, it is a curiosity. If it fell 12,000 years ago, it is a tragedy of biblical proportions. 12,000 years ago, the last ice age was ending. Humans were spreading across the globe. They were in North America. They were hunting, building fires, looking up at the stars. Did they see it? Did they see the sky turn white? Did they feel the ground shake beneath their feet as a city-sized iron bullet reshaped the geography of the North? Some scientists begin to whisper about the Younger Dryas. It is a period in climate history that has always puzzled researchers. About 12,800 years ago, the Earth, which had been warming, suddenly plunged back into a deep freeze, a cold snap that lasted 1,000 years. Ecosystems collapsed. The megafauna, the mammoths, the saber-toothed cats vanished. The Clovis people of North America saw their population crash. For decades, the cause was debated. A shift in ocean currents? A solar anomaly? But now, looking at the jagged scar beneath Hiawatha, a chilling possibility emerges. Did this impact cause the cooling? Did the dust and smoke from this event block out the sun and throw a warming world back into winter? It is a seductive theory. It ties the loose ends of history together with a knot of cosmic violence. But science demands more than theories. It demands a smoking gun. They cannot drill. The ice is too thick, the location too remote, the moving glacier too dangerous for a rig. They cannot touch the crater floor. They are standing on the roof of a locked house, trying to describe the furniture inside. So they go to the river. In the summer of 2016 and 2017, the team lands by the meltwater river that flows out from beneath the Hiawatha Glacier. It is a grey, turbid torrent, churning with sediment, carrying the pulverized remains of the bedrock out to sea. If they cannot go to the crater, they will wait for the glacier to bring the crater to them. They walk the banks of the river, boots sinking into the wet grey silt. The wind is biting, the air cold and thin. They are looking for sand. Specifically, they are looking for grains of quartz that have been tortured. When an asteroid strikes, the pressure is so intense that it changes the crystalline structure of quartz. It creates microscopic parallel lines within the crystal lattice, known as shocked quartz. It creates stiff glass, rock, that has melted and refrozen instantly. These are the fingerprints of a hypervelocity impact. Volcanoes cannot make them. Earthquakes cannot make them. Only a bomb from the stars can make them. Kurt Kjær and his colleagues fill bags with the grey sludge. They fly it back to Copenhagen. They wash it, sieve it, and place the grains under the microscope. They search through thousands of grains. It is tedious, eye-straining work, hour after hour of looking at ordinary sand. And then, there it is, a single grain of quartz, crisscrossed with razor-thin lines. Planar deformation features, the signature of shock, then another and another. They find grains of toasted toast-brown glass. They find elevated levels of platinum and rhodium, metals rare on Earth but common in iron asteroids. The smoking gun is real. The Hiawatha Depression is not a quirk of erosion. It is an impact crater, one of the 25 largest on Earth, and it is sitting right there, hidden under the ice, a sleeping giant that we walked over for centuries without knowing. When the paper is finally published in November 2018, it sends a shockwave through the scientific community. It is a reminder of our vulnerability. We tend to think of the Earth as a closed system, a safe room where history happens on the ground. But the Hiawatha crater reminds us that the roof is open. It reminds us that the peace of the Holocene, the stable climate that allowed civilization to rise, is an exception, not the rule. The world beneath the glacier is not just a place of quiet, slow-moving water and ancient mud. It is a crime scene. As the news breaks, the focus shifts back to the ice itself. The glacier covers the crater, but the crater also shapes the glacier. The heat from the impact would have lingered for thousands of years. Even now, the fractured rock beneath the basin might be allowing geothermal heat to bubble up, melting the ice from below. The crater is a bowl that catches the water. It is a subglacial lake in the making, or perhaps a subglacial swamp, a slushy, pressurized pocket where the ice loses its grip on the rock. The radar shows the layers of the glacier buckling and folding as they flow over the rim and dive into the depression. It is a disturbance in the flow, a hiccup in the ice stream that affects how the glacier moves, how it melts, and how it dies. But the terrifying aspect that keeps scientists awake is not just about what happened. It is about what we still don't know. The dating remains elusive. While the ice looks young, the rock tells a confusing story. Is it possible the crater is older? 50 million years? 60? Did it kill the dinosaurs' final descendants instead of the mammoths? Or is it, as the disturbed ice suggests, a fresh wound? If it is young, it means that city killers are not rare events from the dawn of time. It means they can happen now. It means that the seemingly solid, immutable timeline of human progress can be reset in an instant by a rock drifting in the dark. And there is something else. The Hiawatha crater is just one. In late 2018, as the team pores over more data, they spot another shape, just 183 kilometers away. Another circular depression, another possible rim, a second impact, perhaps a twin, perhaps a partner in destruction. The Earth hides its scars well. It covers them with water, with forests, with shifting tectonic plates. And here, in the high north, it covers them with ice. The ice is a keeper of secrets. It preserves the past in a deep freeze, locking away the evidence of climates that shifted and ecosystems that vanished. But it also hides the violence. It smooths over the catastrophic, turning a scene of absolute devastation into a pristine white canvas. We look at the Greenland ice sheet, and we see stillness. We see a landscape that seems eternal, frozen, asleep. But beneath the scar of Hiawatha, the rock remembers the fire. It remembers the second when the sky fell, and the water that flows through that shattered basin, trickling through the cracks of shocked quartz and iron dust, carries the memory of that impact out to the sea. The discovery fundamentally changes how we look at the white map. It is no longer just a covering, it is a shroud, and we are left to wonder what other monsters lie buried in the dark, waiting for the right radar pulse, the right angle of light, or the right curious mind to reveal them. The ice is deep, and its memory is long, but even as we grapple with the violence of the past, the present offers its own kind of pressure. The Hiawatha crater is a fixed point, a scar that will not move, but the water that interacts with it, the meltwater rivers that rush over its rim and pool in its depths, are part of a system that is very much alive. This water does not just sit there, it moves, it builds pressure, and sometimes it explodes. We leave the crater behind now, buried in its frozen tomb, and follow the water. Because to understand the terror of the Greenland ice sheet, we must understand not just the solid ice or the shattered rock, but the liquid force that binds them together. We must look at what happens when that water has nowhere to go, when the pressure builds in the silence until the ice itself can no longer contain it. This leads us away from the ancient impact and into the modern reality of a melting world, to a phenomenon that transforms the quiet surface of the glacier into a chaotic, thundering drain, a place where the hidden lakes beneath do not just whisper, they scream. Imagine standing on the surface of the ice sheet in the height of summer. The sun does not set. It circles the horizon, a pale, unblinking eye. The air is warmer than it should be, and all around you, the ice is bleeding. Blue rivers snake across the white surface. They are beautiful, mesmerizing, crystalline azure channels carving through the snow. They flow with the urgency of a spring thaw, converging, widening, gathering speed. They look like the rivers we know on land, but they are flowing through a desert of ice. And they do not flow to the sea, not directly. Follow one of these rivers. Walk beside it as the water rushes over the slick, frictionless ice. It grows louder, wider. It becomes a torrent, a white water rapid crashing against banks of frozen blue glass. And then, suddenly, it vanishes. It does not flow into a lake. It does not fan out into a delta. It simply drops. This is a moulin, a vertical shaft, a pipe carved by the water itself, plunging straight down into the darkness. Standing at the edge, you can feel the vibration in your boots. You can hear the roar of the waterfall, a sound like a jet engine, echoing up from the depths. The water is falling hundreds of meters, piercing the heart of the glacier, carrying heat and energy from the surface to the hidden world below. These moulins are the injection points. They are the needles delivering the adrenaline of the melt directly into the bloodstream of the ice sheet. And when that water hits the bottom, when it crashes into the bedrock beneath a kilometer of ice, it changes everything. It is here, in the connection between the sunlit surface and the sunless depths, that the true danger lies. The Hiawatha impact showed us that the bed of the glacier can be shaped by sudden violence, but the moulins show us that it is also shaped by a relentless, accelerating fluid attack. As the Arctic warms, these rivers are getting larger. The moulins are opening earlier in the season. They are staying open longer. More water is pouring into the darkness, and down there, in the high-pressure gloom where the ice meets the rock, that water is looking for a way out. It lifts the glacier. It greases the tracks. It turns a slow, grinding march into a slide, and in some places, it collects in vast, hidden reservoirs that hold their breath for years, waiting for the moment to break. The science of 2018 gave us a crater, but the science that followed began to reveal something arguably more unsettling: the plumbing of a collapsing system, the realization that the ice sheet is not a solid block, but a porous, leaking, moving sponge. And deep inside that sponge, the water is doing work we are only just beginning to understand. It is finding ancient channels. It is reactivating old pathways. It is interacting with the sediments, the shocked rocks, and the hidden topography in ways that our models struggle to predict. The discovery of Hiawatha was a shock because it was a surprise from the past. But the movement of the subglacial water is a shock because it is a warning about the future. It tells us that the barrier between the surface and the depths is thinner than we thought. It tells us that what happens in the sun does not stay in the sun. It sinks. It penetrates. It disrupts. We used to think of the subglacial world as a tomb, sealed and silent. Now we know it is a machine, a hydraulic system pumped full of pressurized fluid, creaking under the strain. And as we pour more energy into that system, as we turn up the temperature and open the taps, we have to ask, what happens when the machine breaks? The scar of the asteroid is a reminder of what the sky can do to the ice. But the moulins, the subglacial lakes, and the lubricated beds are a reminder of what the ice can do to itself. One is a singular event, a moment of trauma frozen in time. The other is a process, a slow motion unraveling that is happening right now beneath our feet. And so the mystery deepens. We have found the wound of Hiawatha, but we have not yet healed the patient. The patient is running a fever. The fluids are rushing to the organs, and the doctors, the scientists standing on the ice with their radars and their drills are watching the monitors with growing unease. They know that the ice sheet is heavy. They know the pressure is immense. And they know that water, humble, fluid, yielding water, is the one thing that can bring the whole structure down. The crater was the beginning of a new way of seeing. It forced us to look down with fresh eyes, to see the glacier not just as a climate record, but as a dynamic, vulnerable, and violent landscape, a place where asteroids strike, where rivers vanish, and where the past and the future collide in the dark. And as the sun dips low on the horizon, casting long shadows across the pockmarked ice, the sound of the moulin continues, a roar in the silence, a heartbeat in the void, a signal that the story of the Greenland ice sheet is far from over. It is flowing, shifting, and accelerating, and we are just small, fragile witnesses, trying to read the signs before the ice decides to move again. Because the ice always moves. It flows over craters. It flows over mountains. It flows over the memories of worlds that came before. And in its slow, crushing indifference, it reminds us that it does not need us to understand it. It only needs gravity and time and the weight of a million winters pressing down on the dark. Summer in Greenland creates a sound that shouldn't exist. If you stand in the middle of the ice sheet in July, miles from the nearest coast, you expect silence. You expect the kind of heavy, muffled quiet that comes with deep snow and freezing air. But that is not what you hear. Instead, the air is filled with a roar. It is the sound of water, millions of liters of it, blue and cold and frantic, rushing through channels of ice that look like limestone canyons carved by a desert river. This is the first sign that the sleeping giant beneath your feet is waking up. To understand why scientists are so terrified of what is happening beneath Greenland right now, you have to follow that water. It doesn't just flow across the surface and freeze again when winter returns. It has a destination. It seeks the darkness. It finds a weakness in the ice, a crack, a fissure, a vertical shaft known as a moulin. And then it plunges. Imagine being a drop of that water. One moment, you are reflecting the bright 24-hour Arctic sun. The next, you are falling. You are screaming down a vertical tunnel carved into the ice, dropping hundreds, sometimes thousands of meters in a matter of seconds. You are leaving the world of light and air and entering the high-pressure, crushing blackness of the interior. And when you hit the bottom, you do not stop. You hit the bedrock, the very foundation upon which the ice sheet rests. For a long time, glaciologists thought this water was relatively harmless. They assumed the weight of the ice above was so great, so crushing, that any water reaching the bottom would simply be squeezed out through slow, trickling subglacial channels, eventually finding its way to the sea without disturbing the massive structure above. They were wrong. The water does not just trickle, it pushes back. This is the mechanism that keeps researchers awake at night. It is called basal lubrication. But that term feels too clinical, too gentle for the violence of the physics involved. Think of it instead as a hydraulic jack. When you want to lift a car, you don't use your hands. You use fluid under pressure. You pump liquid into a cylinder. And that liquid, because it cannot be compressed, pushes upward with immense force, lifting thousands of pounds of steel. Beneath Greenland, the meltwater is doing the exact same thing. As it floods into the space between the ice and the rock, it pressurizes. It pushes upward against the millions of tons of ice above it. It lifts the glacier just a fraction of an inch, just enough to separate it from the rough, grinding bedrock that has held it in place for millennia. Friction, the only force keeping gravity from dragging the ice into the ocean, vanishes. And then the slide begins. The ice sheet, untethered and greased by its own meltwater, starts to move. It accelerates. Glaciers that once crept toward the sea at a majestic glacial pace are now sprinting. They are surging forward, dumping ice into the ocean faster than snow can replace it. It is a runaway train, and the brakes have been cut. We see this happening in real time. We see it in the Jakobshavn-Isbrae, one of the fastest-moving glaciers in the world, a river of ice that drains a significant portion of the Greenland ice sheet. In the late 1990 seconds, it began to speed up. Then it doubled its speed. It is now moving at speeds that were once thought impossible for a glacier, tearing itself apart as it rushes to the sea. And this is where the fear sets in, because this process creates a feedback loop, a vicious cycle that feeds upon itself. As the glacier moves faster, it stretches and cracks. These cracks, these crevasses, open up new pathways for more surface water to reach the bed. More water means more lubrication. More lubrication means faster flow. Faster flow means more cracks. The ice is engineering its own destruction. But there is another phenomenon at work here, one that is perhaps even more haunting than the speed of the slide. It is a concept that scientists have recently given a name that sounds like something out of a horror movie, but is actually a precise mathematical reality. They call it zombie ice. The term appeared in a major study, released just a few years ago, sending shockwaves through the climate community. But to understand it, we have to look at how a healthy ice sheet functions. It is a bank account. In the winter, snow falls, adding deposits to the account. In the summer, ice melts or carves into the ocean, making withdrawals. For thousands of years, the budget was balanced. The amount of snow falling equaled the amount of ice lost. The ice sheet remained stable, a permanent fixture of the planet. But that balance is broken. We have been making withdrawals far faster than the deposits can keep up. Zombie ice is the ice that is still attached to the sheet, still looming high above the ocean, still looking for all the world like solid, permanent ground. But it is dead. It is doomed. It is ice that is no longer being replenished by the snowpack upstream. The equilibrium line, the altitude where snow accumulates enough to sustain the glacier, has moved too high. The ice below that line is starving. It is physically attached to Greenland, but dynamically, it belongs to the ocean. It is walking dead ice. It has not melted yet, but the physics of the climate dictate that it must. It is a debt that has been incurred and must be paid, and the payment will be in water. Scientists have calculated exactly how much of this zombie ice is currently waiting to die. The numbers are staggering. Even if we stopped all carbon emissions tomorrow, even if the climate stopped warming this instant, this ice is already lost. It is committed. It equates to more than 100 trillion tons of ice. 100 trillion tons. Try to visualize that. It is enough ice to cover the entire United States in a layer half a meter deep, and it is all destined to melt, to flow, to slide into the North Atlantic, raising global sea levels by nearly a foot. That is the minimum. That is the floor, not the ceiling. That is what happens if we get lucky. This realization changes everything about how we view the landscape of the North. When you look at a map of Greenland, you see a massive white island. But the map is lying to you. A significant fringe of that white mass is a ghost. It is a phantom limb that the planet has already amputated, but which hasn't fallen off yet. The terror for scientists comes from the lag time. Human beings are not good at understanding slow disasters. If a hurricane strikes, we see the wind, we see the flood, we react. But an ice sheet operates on a timescale that mocks our short attention spans. The heat we put into the atmosphere 30 years ago is just now being felt by the ice deep in the interior. The heat we emit today will be melting glaciers a century from now. We are lighting fuses on bombs that will not explode until our grandchildren are old. And beneath the surface, the lubricated slide makes that explosion happen faster than anyone predicted. The models used to be conservative. They treated the ice sheet like a solid block of ice melting on a sidewalk. Predictable, linear, slow. But an ice cube doesn't have rivers running through it. An ice cube doesn't have a hydraulic system beneath it pushing it downhill. An ice cube doesn't fracture and groan and accelerate. The reality is far more dynamic. And far more dangerous, consider the sound of the ice itself. Researchers who camp on the glaciers talk about it. At night, when the wind dies down, the ice is not silent. It moans. It cracks. It booms like distant artillery. These are the sounds of stress, the sounds of a structure that is being torqued and twisted by forces it can no longer withstand. In some places, the entire surface of the glacier drops suddenly. A subglacial lake, a pocket of water hidden deep beneath the ice, has burst. It has drained in a matter of hours, sending a catastrophic flood wave rushing beneath the ice toward the sea. This sudden release of water lifts the glacier even higher, accelerates it even faster, and then drops it back down onto the bedrock with a shudder that can be detected by seismographs thousands of miles away. These are called glacial earthquakes. The ice is shaking the earth itself, and through it all, the zombie ice waits. It waits for the warmer summers. It waits for the lubricating water. It waits to fulfill its destiny. There is a profound sense of helplessness in watching this. For the scientists standing on the edge of the Jakobshavn Glacier, watching a wall of ice the size of a skyscraper break off and crash into the fjord, there is a feeling of witnessing a grand, slow-motion tragedy. They are measuring the vital signs of a patient that has already been given a terminal diagnosis. But why does this specific mechanism, the lubrication, the zombie ice, terrify them more than just the general idea of melting? It is because of the tipping points. Nature loves stability until it doesn't. A system can absorb stress for a long time without changing much. You can push a rock toward the edge of a cliff, and as long as it is on the flat ground, it stays put. But there comes a moment, a single millimeter of movement, where the center of gravity shifts. The rock passes the point of no return. Gravity takes over. The lubricated slide suggests that parts of the Greenland ice sheet are nearing, or have already passed, that tipping point. The friction is gone. The geometry of the seafloor and the bedrock valleys is funneling the ice outward. In some places, the bedrock actually slopes downward as you go inland. This is called a retrograde slope. It is a geological trap. Once the ocean water breaches the ridge protecting the coast, it flows downhill into the interior of the island, beneath the ice. It eats the glacier from the bottom up, chasing the ice deeper and deeper inland. The farther it retreats, the deeper the water gets. The deeper the water, the more pressure it exerts, and the faster the ice melts. It is a runaway collapse that cannot be stopped once it starts. This is the nightmare scenario. The marine ice sheet instability. A domino effect where the retreat becomes self-sustaining, and the lubricant, that blue meltwater rushing down the moulins, is the grease on the tracks. And yet, looking at the surface, you would never know. The beauty of the place is disarming. The ice is a landscape of diamonds and sapphires, rolling white hills under a sky of piercing blue. It looks eternal. It looks strong. It feels solid beneath your boots, crunching satisfyingly with every step. It hides its sickness well, but stick a probe into the ice, drill down a few hundred meters, and you find the truth. The temperature of the ice is rising. The structure is softening. It is becoming what glaciologists call temperate ice. Cold ice is hard and brittle. Temperate ice is soft and malleable. It flows more easily. It deforms. It yields. Greenland is losing its backbone. The sheer scale of the water moving through this system is hard to comprehend. In recent years, during extreme melt events, we have seen rivers on the surface of the ice sheet that rival the width of the Thames or the Hudson. Bridges of ice collapse into them. They carry heat from the atmosphere deep into the heart of the glacier, acting like arteries pumping poison into a body. And when that water reaches the ocean, it doesn't just raise sea levels. It changes the ocean itself. Fresh water is lighter than salt water. When billions of tons of fresh, cold meltwater dump into the North Atlantic, they stay on the surface. They form a cap, a lid of cold fresh water that disrupts the currents. The Atlantic meridional overturning circulation. The great conveyor belt that moves heat around the planet, that keeps Europe warm and the tropic stable is being weakened. The melt from Greenland is throwing a wrench into the engine of the global climate. We are not just melting ice, we are stalling the ocean. This is the interconnectedness that haunts the data. You cannot touch one part of the system without vibrating the whole web. The drop of water that falls down a moulin in Greenland eventually laps against a seawall in Miami or floods a rice paddy in Bangladesh. The zombie ice that dies in the Arctic is resurrected as a storm surge in the tropics. But let's return to the darkness beneath the ice, because that is where the story is being written. In the dark, the water is not just a lubricant, it is an erosive force. It carries sediment, rocks, and silt. It grinds the bedrock smooth, polishing it, making it even slipperier for the ice that follows. It is preparing the slide. It is smoothing the runway. And sometimes the water freezes again, but not in the way you might think. When subglacial water refreezes at the base, it can attach itself to the rock and the ice simultaneously. It creates a sticky spot, a point of high friction. You might think this is good, that it slows the glacier down. But in a system under this much tension, sticky spots are dangerous. The ice behind the sticky spot piles up. The pressure builds. It builds and builds until the stress overcomes the strength of the ice. And then it snaps. A rupture, a sudden lurch forward. This stick-slip motion creates tremors. It fractures the ice above. It destabilizes the intricate balance of forces that holds the sheet together. It is a violent, stuttering progression toward the sea. And what of the human element? The people who live in the shadow of these giants. For the Inuit communities in Greenland, the sound of the ice changing is not scientific data. It is the sound of their home breaking. They see the fjords choking with icebergs that are too big, too many, too fast. They see the hunting grounds vanishing. They see the sled dogs struggling on ice that is now slush. They are the first witnesses to the zombie ice. They are watching the funeral procession of a world that has sustained them for generations. And for the scientists, the men and women who fly over these white expanses in planes laden with radar and lidar, the feeling is often one of grief. They are chroniclers of a disappearance. They are mapping a coastline that they know will look different by the time they publish their papers. There is a specific kind of quiet in the helicopter cockpit when the data comes in. A silence that settles when the numbers confirm the worst-case scenario. It is not panic. Panic is for immediate danger. This is something deeper. It is a heavy, settling realization of inevitability. They know that the lubricated slide is not just a theory. It is a machine that has been switched on, and we do not know where the off switch is. We don't even know if there is one. Imagine a skyscraper made of glass. Now imagine that the foundation is turning to liquid. The building doesn't fall immediately. It creaks. It groans. Cracks appear in the windows. Doors stop closing properly. That is Greenland today. The structure is still standing, but the foundation is fluid. The zombie ice is the upper floors of that skyscraper. They are still high in the air, offering a view of the horizon. But the supports below them have already failed. It is only a matter of time before gravity claims what is hers. This brings us back to the central paradox of the Arctic. It appears static. It appears frozen in time. A photograph of Greenland taken today looks much like a photograph taken 50 years ago. But a photograph cannot capture velocity. It cannot capture the roar of the water in the moulin or the groan of the bedrock under shifting weight. We are deceived by the slowness of the ice. We mistake slowness for safety. But in geology, slow forces are the most powerful. They are the ones that grind mountains to dust and reshape continents. And now, thanks to our influence, those slow forces have been given a shot of adrenaline. The slide is lubricated, the zombies are walking, and the physics are unforgiving. As we descend from the surface, leaving the bright sun and the rushing rivers behind, we have to confront what this means for the future. We are not just losing ice, We are losing the archives of our planet's history. We are losing the air conditioner of the Northern Hemisphere. We are losing the stability that allowed human civilization to flourish for the last 10,000 years. The terror scientists feel is not for themselves. It is for what comes next. It is for the realization that the map of the world is being redrawn by water and gravity, and we are just standing on the shore, watching the tide come in. But the story doesn't end with the ice sliding into the sea. Because once that fresh water hits the ocean, it begins a new journey. A journey that takes it deep into the currents of the Atlantic, disrupting the heartbeat of the ocean itself. And that journey leads us to an even stranger, darker possibility. For if the ice is melting from below, if the water is warm enough to lubricate the slide, could it also be warm enough to support something else? Could the very destruction of the ice sheet be creating a habitat? As the glaciers retreat, they expose landscapes that haven't seen the sun in 1,000,000 years. They release nutrients into the water that spark blooms of plankton and feed entire ecosystems. In the midst of death, there is life. And in the deep, dark, pressurized waters beneath the sliding ice, where the friction generates heat and the rock provides minerals, there may be secrets waiting that have nothing to do with climate and everything to do with biology. But to find them, we have to look past the terror. We have to look past the zombie ice and the crumbling edges. We have to look into the meltwater itself, because that water, destructive as it is also the cradle of creation. It flows from the dying ice into the living ocean. It bridges the gap between the frozen past and the liquid future. And as it flows, it carries with it the memory of the winter that lasted 1,000,000 years, and the warning of the summer that never ends. The lubricated slide is not just a mechanism of collapse. It is a transformation. The solid world is becoming liquid. The fixed world is becoming fluid, and we are learning, painfully, slowly, that we cannot stand still on a moving planet. So, listen closely next time you see a picture of an iceberg. Don't just see the white beauty of it. Listen for the splash. Listen for the groan of the glacier that birthed it. Listen for the sound of the zombie ice marching toward the sea, because that sound is the ticking of a clock, and it is ticking louder every day. We are living in the era of the slide, and the ground beneath our feet is not as solid as we think. We began this story with the paranoia of men in uniforms, digging into the crust of the world to hide weapons of war. They looked at the Greenland ice sheet and saw a fortress, a white, impenetrable shield that could conceal their ambitions and protect their secrets from the sky. They saw the ice as static, a frozen stage upon which the drama of human conflict could play out, indifferent and unchanging. But looking back now, across decades of data and discovery, there is a profound irony in how wrong they were. The ice was never a fortress. It was never static, and it was certainly never indifferent to the changes we were bringing to the world. It was listening in its own slow geological way, and now it is responding. The journey from those early, shivering days at Camp Century to the satellite-monitored, computer-modeled anxiety of today is a journey from ignorance to a very specific kind of dread. We used to fear what the ice could hide: enemy bases, nuclear silos, the frozen remnants of the past. Now, we fear what the ice can do. We fear the physics of it. We fear the simple, relentless logic of water seeking its way to the sea. And most of all, we fear the realization that the systems we thought were eternal are actually fragile, balanced on a knife edge of temperature and friction that we have already begun to tip. The water we have spent so much time discussing, those hidden lakes and twisting subglacial rivers, has transformed in our understanding. Decades ago, it was a scientific curiosity, a strange anomaly that puzzled the drillers and delighted the theorists. It was a ghost in the radar data, a wet spot in a frozen desert. We wondered if it held ancient life, if it preserved the chemistry of a younger Earth. We treated it like a buried treasure chest, waiting to be opened. But today, the context has shifted darker. We now understand that this water is not just a passive resident of the dark. It is an active agent of destruction. It is the grease in the gears of a machine that is programmed to dismantle itself. There is a tragic poetry to this. Water is the element of life. It is what we search for on Mars, what we listen for in the static of the cosmos, what makes our blue planet a jewel in the void. Yet here, beneath the crushing weight of the Greenland ice sheet, water is the enemy of stability. It is the mechanic that unlocks the friction holding the ice back. Every liter of meltwater that trickles down from the surface, plunging through moulins into the black depths, carries with it the heat of the sun and the energy of the fall. It gathers in those hidden lakes, lifting the ice, reducing the drag, turning a slow, frozen creep into a slide. It is a feedback loop, a snake eating its own tail, where heat creates water, water creates speed, and speed delivers the ice to the ocean to melt and raise the seas, warming the climate further. This is the source of the terror that scientists speak of in hushed tones at conferences and in the introductions of academic papers. It is not the terror of a horror movie. There are no monsters swimming in the dark waters beneath the ice, no ancient beasts waiting to thaw and wreak havoc. The terror is far more subtle and far harder to escape because it is built into the laws of physics. It is the terror of momentum. It is the realization that once a system this massive, this heavy, and this complex begins to move, it becomes almost impossible to stop. We often personify nature to make it easier to understand. We say, the wind howls, the ocean rages, the volcano is angry. But the ice sheet is not angry. It is not vengeful. It does not hate the cities on the coastlines that will be swallowed by its melting. It does not hate the civilizations that pumped carbon into the sky. It simply obeys gravity. It obeys thermodynamics. It obeys the friction coefficients of rock and water, and that indifference is what makes it so terrifying. A monster can be fought, a beast can be killed, but you cannot fight a phase transition. You cannot negotiate with a melting point. The ice does what it must do, what it has always done, only now it does it faster, fueled by the heat we have wrapped around the planet like a blanket. The hidden lakes beneath Greenland act as a kind of battery for this process, storing the potential for rapid change. When we look at the radar maps, seeing those pockets of liquid trapped beneath billions of tons of ice, we are looking at the engine room of a catastrophe. We know that these lakes can drain in flash floods, rearranging the plumbing of the entire ice sheet in a matter of days. We know they can lubricate the bedrock so effectively that the ice above accelerates, surging toward the sea as if impatient to be done with being frozen. We are watching a geological giant wake up, stretching its limbs, and finding that the floor beneath it is slippery. This realization forces a kind of humility that is rare in the modern world. We like to think of ourselves as the masters of our environment, the architects of the Anthropocene. We move mountains, we divert rivers, we split the atom. But standing on the edge of the Greenland ice sheet, listening to the roar of meltwater vanishing into the abyss, we are reminded of how small we really are. We are tinkering with forces that operate on scales we can barely comprehend, setting in motion a chain of events that will play out over centuries, long after the hands that turned the key have turned to dust. The story of the water beneath the ice is also a story of time. These lakes and rivers are time capsules, yes, but they are also hourglasses. They measure the rate of our decline. Every time a subglacial lake drains, every time a new channel opens, grains of sand slip through the pinch. The stability of the Holocene, the climate window that allowed humanity to build farms and cities and civilizations, was built on the assumption that the ice would stay put, that the poles were frozen pillars holding up the roof of the world. Now we know the pillars are wet. We know they are sliding. And we know that the roof is coming down, not all at once, but in a slow, grinding collapse that will reshape the maps of the world. And yet, even in this somber reflection, there is the enduring pull of the mystery. The fear does not extinguish the curiosity. It only sharpens it. We still send our radar planes over the white expanse. We still drill our cores and drop our probes. We still want to know what is down there, in the dark and the cold. Because to understand the ice is to understand our future. We are bound to this frozen world, connected by the invisible threads of the atmosphere and the ocean currents. What happens in the silent, sunless caverns beneath Greenland does not stay there. It travels. It rises in the tides of the Pacific. It shifts the weather patterns over Europe. It alters the salinity of the Atlantic. The labyrinth is local, but its consequences are global. There is a strange beauty in the mechanism, even as it threatens us. The way water finds a path through solid ice, carving cathedrals of glass in the deep. The way pressure melts the base of the glacier, creating a hidden river that flows uphill. The way the ice sheet breathes, lifting and settling with the seasons. It is a reminder that the earth is dynamic, that it is alive in a way that stone and steel are not. We are living on a restless planet, one that constantly rewrites its own surface, and for a short while, we forgot that. We thought the map was finished. The ice is reminding us that the map is merely a snapshot of a moment in time, and that the moment is ending. As we conclude this chapter of our journey into the cold, we are left with a feeling that is difficult to name. It is part awe, part grief, part anxiety. We have peered under the hood of the planet's cooling system and found that the engine is running hot, that the coolant is leaking, and that the gears are stripping. We have found that the solid ground we stood on is actually a slow-moving river, lubricated by the very thing that signals its demise. The frozen lakes beneath Greenland are not just scientific anomalies. They are warnings written in water and darkness. But Greenland, for all its immense size and terrifying potential, is only one piece of the polar puzzle. It is the northern sentinel, the canary in the coal mine. But if you turn your gaze to the bottom of the world, to the vast, frozen continent that anchors the south, you will find a mystery that dwarfs even this one. Because beneath the ice of Antarctica, there are not just scattered lakes and rivers. There are entire inland seas, bodies of water so large they have their own tides, sealed away for millions of years, holding secrets that make the Greenland lakes look like puddles. If the water beneath Greenland is a mechanic of destruction, the water beneath Antarctica is a vault of alien possibilities. There, the lakes are not just lubricants for the ice. They are potential habitats for life forms that have not seen the sun since before the first humans walked the earth. They are the closest thing we have to the oceans of Europa and Enceladus, right here on our own planet. The physics there are different, the stakes are higher, and the things waiting in the dark are even stranger. So, if you found yourself captivated by the silent power of the water beneath the north, you have only seen the beginning. The true depths, the true isolation, and the true wonder lie in the south. If you want to continue this descent into the frozen unknown, to explore the largest subglacial lake in the world and the strange creatures that might call it home, you should click on this video about Lake Vostok next. The ice is deep and the story is far from over. I'll see you there, in the dark.